The carbon footprint of milk. The carbon footprint is referring to the total greenhouse gas emissions from producing milk on the farm. It doesn't take into account what happens between the farm gate and the dairy foods you consume, just what happens on the farm. About once a minute a cow is going to burp, and when it does it emits methane, and methane is a greenhouse gas. Production of cattle feed, tractor fuel, and other inputs also results in carbon emissions, and carbon is also a greenhouse gas. And we're going to always state greenhouse gas emissions in terms of carbon equivalent units. And to see what I mean, consider this little thought experiment. 1 ton of methane, it has about the same warming effect as 21 tons of carbon. We know that. And when I say carbon, I'm referring to carbon dioxide. So a farm that emits 1 ton of methane and 1 ton of carbon is said to have a total carbon footprint of 22 tons of carbon dioxide equivalent units, or we'll say it succinctly throughout, 22 tons of carbon. So every time I say carbon, I'm referring to carbon dioxide equivalent units. This graph tells a story of what's been happening in the dairy industry throughout the last century. Let me first draw your attention to the red line. The red line, its values, the x-axis here are the years 1924 to 2013. The red line refers to the number of dairy cows and its values on the left y-axis. And we see that between 1940 and today, the number of cows we have on dairies throughout the U.S. has fallen, and has fallen a lot. Does that mean milk production has fallen? No, it does not. This green line tells us total milk production measured in 10,000 pound units. Its values are also on the left y-axis. And total milk production has been rising throughout this time. So at the same time we've reduced our dairy herd size considerably, we've been producing more milk. Well, the only way that can happen is if each cow is more productive. And indeed, this blue line tells us the pounds of milk on average produced by each cow each year, and it keeps rising, rising, rising. And what this means is that if we're able to produce more milk with less cows, that's less cows burping, emitting greenhouse gases. If we're able to produce more milk with less cows, that means that there's less cattle feed, less inputs that need to be used on a dairy farm. Perhaps at the same time that we're increasing milk production, we're lowering the total carbon footprint of milk. That's something we're going to ask and see whether that is the case. To give an idea of these productivity gains that's occurred, to produce 1 gallon of milk today requires this. I went to a dairy farm and calculated all this. 1 gallon of milk requires 2 gallons of water and 10 pounds of this feed. And this feed is alfalfa hay, Bermuda grass hay, cotton seeds, soybean meal, and various vitamins and minerals. Now let's ask how much of that water and feed it would take to produce a gallon of milk in 1945. It would take 5 times as much. Whereas today we produce a gallon of milk with 2 gallons of water. In 1945, it took 2, 4, 6, 8, 10 gallons of water. Today, to produce 1 gallon of milk, it takes 10 pounds of this feed. In 1945, it took 10, 20, 30, 40, 50. Now, all this extra water and feed that had to be produced, it required inputs that emitted carbon. And so it could be that, well, certainly we know that a gallon of milk produced today emits less carbon than a gallon of milk produced in 1945. But the question is whether the total emissions from all dairy production in the U.S. today are greater than or less than the total emissions in 1945. And we're going to do a calculation to see if that's true. This is a calculation. I never refer to these things as facts. These are good calculations based on good numbers. It's good evidence. But again, nothing, you can't really have anything you say as a solid fact in this area. We want to know whether total carbon emissions today are greater than or less than in 1945. We don't care about what that level of carbon emissions is. So we're just going to let the total emissions in 1945 from all dairy production be X. Now we know that today producing 1 gallon of milk results in 1/3 of the carbon emissions than it would have in 1945. So if we were still producing the same amount of milk as we were in 1945, total total carbon emissions would be 1/3 of that amount, that X divided by 3. But in fact, we are producing much more than X. Milk production has risen 68% since 1945. What that means is the total carbon footprint today is, and this is how we do this calculation, X is the 1945 level. I multiply it by 1.68 to increase production by 68% to bring it to current milk production levels. Then I divide it by 3 because there's 1/3 of the carbon emissions for each gallon of milk produced today relative to 1945. In the end, this means total carbon footprint today is 0.56 times the carbon footprint in 1945. Despite producing 68% more milk, the total carbon footprint from U.S. dairy production is almost half as much as it was in 1945. I think that's just an amazing result. It's nice to see. It means that we are able to get cheaper milk, feed more people, while reducing total carbon emissions. Now, some people think that these emission reductions are not enough, and maybe they're not. So I should add here that if you wanted emissions to be even lower than 0.56x, you could maybe substitute milk for something with a lower carbon footprint. Or there are other things you can do on the farm to reduce the carbon footprint even more. There's experiments where they're trying feeding cows different things to reduce methane emissions. We've seen that there is a surge of productivity in dairy cattle in the last century. Well, where is it coming from? Animal scientists have calculated that 2/3 of the productivity improvements are due to better genetics. Remember, we saw this video of a cow being artificially inseminated. And artificial insemination has been revolutionary for the dairy industry because it allows the dairy industry to identify the best bulls, meaning the bulls that have offspring that produce the most milk, and to take that bull and have it impregnate as many cows as possible, thousands and thousands, perhaps millions, I don't know, all across the world. So it's much easier to get good genetics in dairy herds today because of science, because of modern technologies like this. And 1/3 of the productivity improvement is due to better management and feed. The science of nutrition is a science. It's amazing the things they do with cattle feed now. Really, the dairy farmer spends much more time making sure their dairy cows get the right nutrition, more time on their dairy cows than they probably do at their kids at home, and even themselves. And there's other things that farm managers have learned to do with dairy cows that's made them more efficient. So 2/3 goes to genetics, 1/3 due to better management and feed. I think the important thing to point out here is these improvements have reduced the total carbon footprint of milk, even though no one actually set out to do that. Dairy farmers were just trying to be more efficient to reduce their costs. Animal scientists were trying to learn more efficient methods so that we could reduce the price of food. We did all this, made efficiency improvements, and got this great side effect that the carbon footprint has fallen as well. Selective breeding in dairy cattle. Up until around the time of Henry VIII in England, little care was given to what cows would be bred with another. In another lecture, I talked about how King Henry enclosed the commons and converted it to private property, giving big landowners the monetary incentive to increase productivity. At the time, cattle were better described as different races in each region as opposed to different breeds. Each region had its own particular genetics, and people were not eager to import the genetics of another region. The black and white cows you see here and in every Chick-fil-A commercial are referred to as Holsteins in the U.S. and Friesians elsewhere. Every now and then a recessive gene will cause them to be red and white. They are called Holsteins or Friesians because this line of cattle was developed in both the Friesland of the Netherlands and the Holstein region of Germany. These cattle were imported to the U.S. at different periods, but most of today's U.S. Holstein cattle can trace their ancestors back to the imports arriving between 1877 and 1905, and these are the most popular dairy breed because of their superior milk production. The smaller brown cows are Jersey cattle, which originated from the Isle of Jersey in the English Channel. Although a single Jersey produces less milk than a single Holstein, Jerseys convert feed to milk more efficiently. Holsteins therefore produce more because they eat more. This farm had only a few Jerseys until the price of corn rose to historical levels, at which point they integrated more Jerseys for their more efficient conversion of feed to corn. Milk from Jersey cows are also higher in butterfat, and if butterfat is scarce relative to fluid milk, the output of Jersey cows can elicit a higher price than their Holstein counterparts. For these reasons, Jerseys can be more or less profitable than Holsteins, based on the price of feed and consumer demand for milk, cheese, and butter. Interestingly, while the Jersey cows are gentle and have a gregarious personality, the meanest animal I have ever seen in my life was a Jersey bull. I hear Holstein bulls are no better. Until 1750, very little attention was given to the bull that would be used for breeding, when today that is the most important choice a farmer can make. This might be because they had no system for collecting data, and so no good system for designating which bulls were superior. The quality signals they relied on were flawed. When a farmer in the Elizabethan age set about trying to determine whether a cow would produce a lot of milk, they might look at the direction of its hairs on the rear part of her udder, a custom which had about as much validity as the many superstitions that existed at the time. Today, milk production is a highly advanced science, and an enormous data collection program has been established, allowing dairy producers to use statistics, not myths or tradition, to identify the best genetics. So if the carbon footprint of your milk is a major concern for you, then nothing is more important than the semen the farmer buys to impregnate the heifer. The good news is you don't have to worry about whether the farmer is reducing the carbon footprint of milk. The farmer has even more incentive than you to get milk with fewer inputs. And so this increase in productivity and reduction in carbon footprint over the last century came about by farmers doing what they do best, increasing the productivity of their animals. It came about out of the farmer's self-interested pursuit of profits, not concern for the environment, as global warming did not exist as an issue in, say, 1945. The same thing goes for better nutrition, the second most important reason for higher dairy productivity. Before the 16th century, a lot of farmers would slaughter much of their livestock in the fall because they could not produce enough feed to carry them through the winter. This changed once they learned to grow turnips for a winter feed. Over the next few centuries, small advancements in nutrition were made, but still, even in 1900, the science of nutrition was hardly a science at all. Now, more thought is given into what these cows eat than what we feed our pets, or even ourselves. Today, computer programs are used to determine exactly what cows will be fed, and this program is used to deliver exactly what the cow needs at each stage in its life at the least cost. Farmers can purchase some of these programs themselves to determine their feed formulations, use free programs provided by university scientists like the Spartan 3 program by a professor at the University of Illinois, or hire consultants to design feed formulations for them. Whatever strategy is taken, the feed will be determined based on the size of the cow, whether the cow is lactating, an enormous amount of data on nutrition requirements and milk prices, and a computer optimization routine to make sense of it all. This is one reason why students in agricultural economics and animal science learn mathematical optimization algorithms in college, since roughly half of a dairy farm's cost is feed, and since small deficiencies in nutrition can cause considerable shortfalls in milk production, a farmer can thrive or go bankrupt based on her feeding strategy.